If you're a fair dinkum full-blown Aussie, you'll know full well what this engine is. But if you're not a fair dinkum full-blown Aussie, what it is a Ford Falcon single overhead cam inline 6. Now these bad boys are a 4-litre inline 6 engine that they ran from 1988 all the way up until 2002. Now that might seem like a long run for an engine, and quite frankly it is, but Ford made a lot of small adjustments along the way from the original single overhead cam engine right up to the Intec, which they finished making in 2002. Now, what are we going to be doing today? Well, going to be pulling apart this engine to give you guys an insight into why they are such a good engine, why they have such a presence in the automotive performance industry and general automotive culture here in Australia. We're going to be talking about what makes them so good, what problems they had, what things you can do to them to make them faster, the general architecture of the engine, and interesting things that we find along the way. And this is going to be a part of a series of videos that I'm going to make pulling apart classic Australian engines to see why they are classic Aussie engines. Now this particular bad boy was given to me by a mate of mine from TAFE. It was going to the scrappers and I thought, surely not, you can't do that. Because this is, quite frankly, a marvel of engineering. And they are a motor that's fairly close to my heart because I am a Ford Falcon man. I'm an anything car bloke. I'd even own a Commodore, to be honest, but I've owned a lot of Falcons in my time and I can tell you, these things love a thrashing. They absolutely froth being sat on Limmy for hours on end. If anything, it probably makes them last longer, and if you've got oil in them, they will continue to keep running. So without further ado, let's start stripping this bad boy down to see why I can sit them on Limmy around a roundabout all night. Let's get cracking. The thing about Ford is that they don't really like naming engines. So like with Toyotas, they have an engine name for every single family of engines and every single series, but in Australia these things are pretty much just called single overhead cam Falcon engines or 4-litre single overhead cams. They don't really have a specific numerical name, or like they're not called a Barra or anything like that. A lot of people do like calling them Intecs. If they see a single overhead cam they go, oh, it's got an Intec in it. Well, that's not correct per se, because the Intec came out with the AU Falcon. Some people like to say very late EL Falcons had Intecs. They were more of like a crossover engine with bits of both worlds. But for now, we're just going to call this a single overhead cam 4-litre, and it originated, this style of engine, in 1988 when Ford released the EA Falcon. And originally they came out in a 3.2 litre variant and a 4.9 litre variant. They ended up dropping the 3.2, just keeping it the 3.9, and then they upsized it to 4 litres in the EB Falcon, which from memory came out in about 1990 or thereabouts. From that point on, all the way up to the very end of the Falcons, they kept the 4-litre displacement. I believe they even kept the same bore and stroke right up to the very end of the Barras. So obviously they must have figured something out, realised that that was a good displacement, a good rod ratio, whatever, right until the very end. But this one here, I can tell you guys, is approximately a 1994-95 engine out of an EF Falcon, and the reason I can tell you that is that it has, of course, this big banana manifold with the dual inlet runners. It also has a cam angle sensor as opposed to a distributor. So Ford always used a distributor with the TFI module on it, similar to American stuff. Up until the EF, they went to a cam angle sensor and a coil pack brick similar to like an Ecotec Commodore. They realized that that system was horrifically unreliable, and then they went back to a distributor for the next model, EL Falcon, which is one of these rare occasions where a manufacturer has gone to a more modern technology and actually gone back to an older technology purely for reliability, even though the distributor had its issues anyway. So this engine of course, is a TAFE engine given to me from TAFE, and that means that it is partially stripped apart. So it makes it super easy to, bam, pull that rocker cover off. Look at that bad boy. It's actually pretty clean inside. Beautiful. Big aluminium casting, actually quite heavy. But yeah, I love aluminium casting. I love aluminium rocker covers in general because everything's plastic these days. Love opening a bonnet and seeing a big aluminium rocker cover. Straight off the bat, you can see all the rocker gear here. These are an interesting engine in the way that they actuate the valves, of course, as the name suggests, single overhead cam. The cam's run by a dual row timing chain, very stout, very grouse. But of course, only 2 valves per cylinder, which is fine. 2 rocker shafts. Each rocker shaft has its own set of 6 rocker arms on it. And if we flip it over, what you'd expect to see is the bearings / journals for the cam integrated into the rocker shafts assembly. And as you can see, that is definitely not a machined surface. So the cam itself is not actually supported on the top. That is quite interesting because you think to yourself, well, okay, what's stopping it from moving up out of the cam journals in the cylinder head? Well, it's actually all to do with valve spring pressure. So there is always going to be a rocker arm pushing down on the cam in multiple places, holding the cam down into the cylinder head. Now that we've got this rocker shaft flipped over, you can see the arms themselves. They're actually quite big, beefy units, cast aluminium, and in the tip of each rocker shaft is a hydraulic, well, they call them hydraulic lifters, but it's probably better to be called a hydraulic lash adjuster, but Falcon terminology always calls them lifters. That's what they look like. Might be a little bit difficult to see because the camera might not focus. It's got kind of like a swivelly head on it, and of course that is fed oil pressure from the oil pump and keeps valve lash to practically 0. I have had to replace a set of these on a car that an old person had. I think they just gum up with oil, especially if the car's been sitting, had poor maintenance, low oil change count. But other than that, there's no real problem areas in this top end. If anything, it's probably overly engineered. Really nice design, at least in my opinion. Nice and easy to work on as well. And one other beautiful thing is that on the rocker arms, they have little roller bearings that actually ride on the camshaft. That reduces friction, reduces wear, makes them last longer. It's just a nice design. If this was in the 1960s, you'd call this a race engine. You really would. With that removed, you can see these exhaust and inlet valves, and you can also see that they are really quite canted. There's a long-held belief that if you have valves canted in at an angle, it increases the flow of air in and out of the engine. Of course, modern technology, modern head design, they actually are going away from a canted head design and using some very steep valve angles due to like forced induction, all that sort of stuff. So you don't really see this sort of architecture these days, especially with dual overhead cam engines. In the olden days, say 2019, 2020, pre-COVID times, I used to work for an engine shop called Waggett Cams, and we had to grind a fair few of these single overhead cams, primarily for speedway. So around this area, speedway is probably the most prolific form of motorsport, and most vehicles that they run are Falcons and Commodores, or at least it was. I think we're going to have to start looking for different types of vehicles to run as the Commodores and Falcons die out. But that's the cam there. I really like the look of these cams because when you physically wrap your eyes around them, the cam lobes themselves are quite large. Doesn't mean that they have much lift because the base lobe is quite large as well, but it just means that there is a lot of room to move, because as you remove some of the base lobe of the cam, you're actually increasing the total lift of the cam. The next thing that I'd like to talk about is the inlet manifold. So luckily we've still got the inlet manifold, all of the injectors still in situ on this engine. They do have a very distinctive look about them. They even kept this style of inlet manifold right up until the end of the BF Falcon Barra motor in about 2007. Then they went to like a plastic ugly looking thing. I like them. I really like the look. It's super distinctive, super Australian, and the reason it looks like this is because it has dual inlet manifold runners built into one manifold. A lot of manufacturers have used this style, including Toyota. I think they called it T-Viz on their 4AGEs and stuff. But when the vehicle hits about 2,850 RPM, it actually uses this vacuum diaphragm here, controlled via a VSV valve or like a vacuum solenoid, if you will, switches it over to the other set of runners. So at lower RPM, of course, your air has to travel around a long runner. That increases the torque of your engine. As you increase the RPM and therefore just want more ability to have airflow enter the engine, they switch to a shorter manifold runner and increase the total power. Well, that was a bit of a pain in the butt, especially considering that there's about 20 billion 8mm bolts and a whole bunch of wires going into places that you can't immediately see. But we've got the inlet manifold off, and when you do, it really neatens up the look of the entire engine. All of a sudden, you're really left with just a beautiful big inline-six cylinder, block and head, and it looks like absolute majesty. I thought it'd be a great idea to ask Davo, the mechanical wizard, about his thoughts on these engines. Considering he was a mechanic for 43 years, he even worked for Ford at the time of the release of these engines in the original 3.9 litre variant. And I asked him, what are these engines like? What goes wrong with them? And he said, well, in all honesty, they are actually a pretty good engine. Their main issue was in the earlier variants, they like to do head gaskets. They blow head gaskets quite often. There are cases where they probably only made it to 100,000 Ks and blew the head gaskets, and sometimes it would happen regardless of whether the car was cared for or not cared for. And I think the main issue was twofold, probably threefold. The first issue is, of course, you've got a massive cast iron engine block and a massive aluminium cylinder head. You've got a difference in metals, and of course different metals have different expansion rates when they heat and cool. What that means is that you essentially have a cylinder head and engine block that are kind of cribbing against each other all the time, and that actually to an extent wears the cylinder head, puts more the cylinder head gasket puts more stress on it, and it even actually kind of wears the surfaces at which the head gasket is sitting between. The second thing is that Ford used like a composite material head gasket, like that older style aluminium looking stuff. It was kind of prone for failure. Even Toyotas of this time period had head gasket failures due to that style of head gasket material, I think because they had to go away from asbestos and infused gaskets, and they became a bit crap for a little bit. There's also, from what I can gather, a bit of a water flow issue with these, particularly earlier variants of the Falcons. If you drain the coolant and refilled it and didn't properly bleed the system, they'd get an air pocket in the cylinder head and cause an extreme heat area, and that portion of the head gasket was more likely to blow. Earlier Falcons were quite a pain in the butt to bleed the cooling systems in. That brings us to the next bit of this engine, which is this little bubby thing down here, which is kind of interesting to me because I've never owned a Falcon with this style of ignition, of course, as I said. They only ran these for a few years with this cam angle sensor, which of course allowed the ECU to know what the engine position was and therefore when to fire the spark plugs. So that position, of course, is exactly where the old distributor would go, and of course in the next model along where the distributor would go once again. What I find interesting about this is that this pickup, made in Australia. Of course, pretty much most of this engine was, but quite often Ford would source electrical components from overseas, primarily the mother Ford company, and get a lot of Bosch stuff as well. But this doesn't say Bosch on it anywhere, which is weird. But it is in fact, oh, it's Bosch, made in Australia. Oh. Time for the most interesting part of pulling apart an engine, and that is pulling the cylinder head off. Hoo-wee mama. Straight off the bat, I can say that this engine was actually in pretty good condition. It does show signs of a little bit of oil consumption. It's a little bit clean around the edges of the pistons. It still has crosshatch in the bore, which is nice. Has zero lip on the top of the pistons, the cylinders as well. Head gasket doesn't appear to be damaged in any way. However, it is one of those horrific monotorque head gaskets which are truly terrible. What we've got here is the cylinder head off of this Falcon engine, and as you can see, the combustion chamber is, it almost resembles a kind of somewhat hemispherical design. It is a real dome shape. It does have these sort of tight areas in around the side of the combustion chamber here. Look, a lot goes into cylinder head design. It is the main portion of the engine that creates the power. It pretty much gives an engine its entire attitude, its entire power band, its usability, that of course alongside the cam and its drive. Now, one thing that is really distinctive about these Falcon cylinder heads is the size of the valves. They have really quite a large valve size, not necessarily a huge port design, but the valves are really quite massive. That in conjunction with that really canted valve design means that they do flow fairly well. You can get some pretty good power figures out of these bad boys, especially with a cam, a bit of a skim, get that compression a little bit higher. As you can see, the port design is fairly typical of an engine of this era. You have the little cutout there where the injector sprays down into the inlet port. But this cylinder head has been machined at some stage, of course, to accept a nice fresh head gasket. And of course, one final aspect of it is the fact that it is a massive, big aluminium cylinder head. That is probably its main weakness, really, in that, of course, it does have a different expansion rate to the block, and they are prone to doing head gaskets, especially in the earlier year models of these engines. I think also because they were difficult to bleed meant that you could end up with air pockets in the cylinder heads, and therefore they were fairly likely to, of course, blow in that area. Whee. There you go. Now that we've got the timing cover off, you can see the simplistic nature of the timing chain system on this engine. As you can see, you just got your crank sprocket, your cam sprocket, and this sprocket here, which is the same tooth count as, of course, the cam sprocket. You've also got two guides, so this one here, which is actually the one that is doing the tensioning. This one here is just a stationary guide, of course, to stop slap. Now, the interesting thing about these engines is that they are based off of a pushrod engine. So in the previous generation of engines, so the 250 crossflow, which a lot of Aussies are familiar with, in this section here, you would actually have had a cam that ran all your push rods, so in this exact location pretty much. But in this application, of course, completely useless. And what we've got, I think some people call these a jack shaft, but what it really does is actually runs the distributor, or in this case, the cam angle sensor. The funny thing is, of course, that it is not actually sensing the cam itself, but it derives the position of the cam considering via the fact that it's got the same tooth count. And assuming that you never ever jump any teeth, of course, it'll always be the same as the cam. Now, I'll just remove all this. Super beefy, super heavy, over-engineered. But what we've got here is something a little bit incredible. Of course, that sort of looks like the front bearing journal of a cam, but all we've got is a jack shaft with this gear segment on it, and look at that. Wow, it is completely chewed out. Now, one massive reason that that's probably the case is aftermarket distributor gears, which begs the question, what condition was the cam angle sensor in? Pretty good nick. This is also made in Australia, so generally what happens with these is that the distributor dies. People put aftermarket distributors in them like cheap Chinese rubbish because they, of course, contain the distributor pickup, the TFI module, so the ignition module. When that dies, people just throw a whole distributor in, which sounds like a great idea because, of course, you're replacing everything in one go. Theoretically, you're making the car more reliable by renewing most of the ignition system. But the gear drive on those Ching Wing Charlie distributors doesn't really mesh correctly with the distributor drive on this shaft, and it chews them out really badly. So quite often, say your ignition module will die on your Falcon, you put a new distributor on it, you're actually inducing another issue into the engine, which is far worse by chewing out this gear. But what doesn't make sense to me with this engine is the fact that it has chewed out this gear, but it has an original distributor slash cam angle sensor in it, which appears to have absolutely zero damage. So I'm wondering whether or not that distributor slash cam angle sensor or cam position sensor is not the original one for this motor. Anyway, interesting times. It was at this point where my microphone decided to run out of battery, so the rest of the video was filmed without any sound. But when I tipped this engine over, I found that the sump still had a fair amount of oil and water in it. So it became apparent to me that this engine has probably gone through the floods, the 2022 Lismore floods, and has been sitting around with water in the oil ever since. And you can see when I removed the sump, it was sludge city. But interestingly enough, it hasn't actually done much damage, if any at all, to the rotating section of this engine, and found that everything was pretty much still serviceable. It did make a massive mess on my floor. When I removed one of the pistons and conrods, I found that the piston itself was in absolutely perfect condition, very minimal scoring. The bore was in great condition, but the big end bearing was really worn. It was still probably serviceable, but showed more signs of wear than the piston did. Main bearings were equally as worn, showing that this engine has probably got a few Ks on it, but it is interesting to note that everything else in this motor is extremely serviceable. Well, that pretty much concludes the teardown of this Falcon Inline 6. Now, some of you guys might be saying, well, you haven't pulled out the crankshaft and pulled out all of the other pistons. Well, you pretty much only have to check one big end, one main, and one piston and bore to sort of get a good general sense of the overall condition of this engine. Another reason I'm not pulling them out is that if I do, then parts will get scattered everywhere, and chances are this engine will never go back together. I do want to keep it for future use potentially. I do have a lot of Falcon engines in the shed here, and what I might do one day is make the best Falcon engine using the best parts of every sort of series of single overhead cams. So like an AU Falcon Intech block with an EL Falcon XR6 head with an EA cam and cam gear and stuff like that. Because from what I can gather, you can use all these bits to make yourself a high compression engine with a good cam. I need to do more research. That might not be the case. An AU Falcon might just be the best there is. But this is too good to scrap, so I'm not going to strip it apart. Now, that brings a question. Why is this such a good classic Aussie engine? Well, I think it's a culmination of a lot of different things. And I think the first of which is that Ford in Australia never really did a clean sheet redesign of their Falcon 6. They started off with the American designed 140, 170, 200, 250 non-crossflow with the log type manifold. Ford Australia designed the 2V head with the removable inlet manifold. Then they went to the overhead valve crossflow 250. Then they went to the single overhead cam, and then inevitably they ended up with the Barra motor. And I think because they never really started off with a whole new engine, they just kept getting better and better and better every series. Because, you know, when car manufacturers release new engines, there's always something wrong with them, always. And they end up getting tarnished and what have you. So that, in conjunction with good metallurgy, the fact that they're an inline 6 and inherently smooth, really strong block design, great timing chain design, great valve train design, good cylinder head design, just meant that they were just a really good, stout, long-living engine that gave very minimal issues, other than, of course, the head gasket, which is probably this series' biggest issue. The fact that this one's got a stripped drive gear for the distributor / cam angle sensor, I think that's probably potentially something that has been induced into this engine. Somebody's probably ran a Chinese aftermarket distributor or what have you. It's chewed out that gear. They've tried to diagnose it by putting a the original cam angle sensor back in it. That hasn't worked. The engine sat around. It's gone through a flood. It's ended up at TAFE. A bunch of TAFE students have gotten into it, and now it is here. But of course, I do want to make sure that this engine does live on into the future. Anyway, that concludes this episode. That's why the Falcon single overhead cam is a classic Aussie engine. And we'll see you on another episode where I strip down another brilliant Aussie engine. But to know what it is, you'll have to watch the episode. We'll catch you next time.